So today, 3B, using time series plots. What we're going to do is we're going to do a little analysis with these using these time series plots. Last time you constructed a few of these and remembering that you were plotting each point, getting a correct scale, connecting them all with lines. And today what we're going to do is we're going to see what we can do and how much information we can gather from looking at those plots. And we're just talking about just giving a cursory glance just to see a few things. We're not talking about doing any real mathematics here. We're just going to be glancing at these and seeing if we can see some things that are happening. So let's just go to the textbook. Now, we're going to look at features like trend, seasonality, etc. We're going to define all of these. So, and then at the end, there's also a list of definitions. You may feel free to go through those if you would like. So, the first thing we're going to look at is called a trend, and a trend simply means the tendency that values are having over a significant period of time. Now, you need to be careful because we're going to look at some other things that will seem like a trend, but they really don't cover enough time to be able to be thought of as an actual trend. And if you look at the first graph here, they have their time series, and you see that the actual blue line, the time series line, goes up and down quite a lot. There's a lot of variation. But what they've done is they've drawn this red line here to indicate an overall trend. And we talked about this when we looked at those we were constructing the other day. This trend looks to be increasing over time. So we could say that the trend here is that this data is increasing over time. Now, we don't know what the data represents. We don't know what the time is. We're just talking about what it will look like. If the line is going down, then we could say that this is a decreasing trend. Now, so what we want to do here is you just want to draw what's called a line of best fit. Now, you're not going to do any mathematics here. You could do some very complicated mathematics to determine exactly where this line should be. You're not worried about that. All you're worried about is just to draw a line that gives you an idea what's happening. So just approximate the middle of the line to get your trend. Okay? And again, the key with trend, though, is it's a general increase or decrease over a significant period of time. So you can't just do this if you had just had a week's worth of data, unless that was 1 week was all you were looking for. But that really doesn't determine a trend, right? You need a good length of data, a good length of time, right? So trend is the most important one and one you're always going to be looking for. Now, if you look at this particular time series graph, you're going to see that there are several trends here. And so as long as the time periods are significant, so if you're looking here from, that's a period of 30 years, that's a significant amount of time, you can see that this data was increasing up to a certain point. Then, over the next decade or so, 10 years, still a significant period of time, the data was decreasing. And then here it's decreasing, but not as much as it was on that trend line, the second trend line that we did. Okay? You could also see that data sometimes will level out, will flatten out. And we'll see that as well and talk about how to use that. And hopefully, somewhere in your math background, you learned the word constant. If something is flat, stays the same, then it's constant. It's neither decreasing or increasing. It's constant. So here we have an increase, here we have a decrease, and if the line was flat, now I've just mud that up, this one is actually showing a decrease. But if the line is flat, then we say that line is constant. All right, so you can see why I did not want to redraw all of these on a video for you. Okay, and when you're discussing them, you need to make sure that you're being as specific as possible. Here, for example, the trend one between 1940 and 1961, the birth rate grew quite dramatically. And you can see that's dramatic because it's a very sharp increase. The line is going up quite a lot. Here, we could say that this is a dramatic decrease. Now, with trend 3, from about 1970 to 2000, the trend, or to 1990, sorry, the trend is still a decrease, but a slight decrease. All right, so a slight decline. All right, the next one we want to talk about is we're going to talk about the idea of what's called a cycle. Now, a cycle is just periodic movements, but over a period greater than 1 year. So make sure you remember it. We're still talking about greater than a year. So if you see what's happening here, it goes up, then it goes down, it goes up, then it goes down, goes up, then goes down, etc. Right? And over more than just 1 year, and you'll see why 1 year is important. So you're showing a general cycle. It's up and then down, etc. Okay? Now, it's not up and down the same amount every time. That's not important. But what is important is that you're seeing this general overall up and down movement over time. And that's called a cycle. So things increase, then they decrease, then they increase and decrease. All right? It can be any pattern, though, as long as it is indeed showing a pattern. Okay? And that's called a cycle. Now, you can also have what's called seasonality. And that should automatically spring to mind that we're talking about over the course of a year or a month, thinking about seasons. These are not years and years and years of data. This is generally what happens within a year. Okay? But it can be even shorter than that. And so if you look here, all of these dates are in 1998 or 99, and then the 2000s. So we're talking about, in this case, a quarter. So the different measures of different quarters in a year, and you can see that we're seeing some seasonality. Between March and June of 98, it went down. Between June and December of 98, it went up. Then it went down. So again, you're seeing a pattern, but this is a pattern of less than a year, so it's happening with seasons. So for example, if you thought of fruit production at an apple orchard, you would expect that production to go up in certain times of the year, and you would expect that there to be no fruit production whatsoever at other times of year. It's not going to stay static or constant as you go through. So here we have an overall trend line that it's increasing over the years, but it's increasing in a very distinct seasonal pattern. Okay? So watching for patterns that represent seasons. And again, you might expect this. This is measuring hotel rooms, and what you see is that you get a significant increase between June and December over the summer months, right? And then a decrease when people are back at work and back at school. Then another increase, and then a decrease, and then another increase. And those seasonal increases and decreases are happening generally in the summer in this case, right? So, and finally, the last trend kind of thing we're going to talk about is we're going to talk about something called structural change. Now, structural change is when there's a sudden change in the established pattern. So you're going along, there's an established pattern, then all of a sudden it increases really heavily. So if you look at this data, right along here, it's pretty constant, decreasing slightly. Here, it's pretty constant, it's decreasing slightly. But from here to here, there's a sharp decrease, and then a sharp increase. And from here, there's a sharp decrease. And it stays down once it starts to decrease. Here, it stayed up once it did that sharp increase. Okay? So we're talking about structural changes that still measure a change over time, so it's consistently down, but there was a sharp increase or decrease. Now, this one is talking about some changes in electrical use, and you would expect that to vary over the months. Perhaps when it's warmer, you would expect to use more electricity as people used air conditioning, and when it's cooler, you would expect them to use less, because if this was Brisbane, it just wouldn't be that cold, so you wouldn't have to worry about air conditioning or heating for that matter. Okay, so you see that structural change will happen, and then it stays around in that same pattern. So sharp increase, and then flat, sharp decrease, then flat. Okay. Now occasionally you can get some odd things that happen. And the odd things that happen are called outliers. Outliers mean one particular piece of data, individual data point that just doesn't fit everything else. If you drew a trend line here, this trend is almost constant or slightly increasing, right? But if you see here, in that particular day, on day 4, there was a huge drop. So if this was electricity in a rental house, for example, and it dropped significantly, but it stayed constant most of the other times, you could assume that maybe this was a day that there was no one home, right? Or perhaps the power was even out. Who knows? Something significantly happened here that doesn't fit with the other data. And we call that an outlier. So we don't usually consider those when we're thinking about describing the data. So if we were looking at this and wanting to determine a trend, and because this is one single odd point, we wouldn't really care about that too much. Instead, we would just draw our trend line to represent that this is a slightly increasing amount, or you could even say constant because it's so flat, right? The variation is so small. So we could say that the electricity use per day is fairly constant, with maybe a slight increase over time. Okay? We would just ignore this outlier. Now, if, for example, every 4th day it went down, then we're talking about something different here. We're starting to determine a pattern. It's a type of seasonality, that these things every 4 days, for example, every 4th day, the family may be gone doing something else. So that it represents a pattern. But if it's just once, then you have what's called an outlier. All right? So easy to see, but your job is to make sure that you understand what each one of them is. Okay? All right? And then you can also have what are called irregular or random fluctuations. Not every pattern or time series is going to show a regular pattern of increasing or decreasing or seasonality. There could be just things that happen that just cause an irregular fluctualities. And then if that's the case, then you're not going to be able to predict what's going to happen in the future based on what's happened in the past. But in most time series, you're able to predict the future behavior of a line based on its past behavior. But if it's irregular, you're not going to be able to do that. So let's look at the ones we've done. So these are the definitions that you have to make sure that you understand, and they put them here a lot easier than the other definitions as they gave them so very much smaller. So you need to determine a trend. Now again, we can just draw a line, and that has to be over a long period of time, okay, to see what the trend is. You may be able to look at the time series to determine if there are cycles. Again, cycles happen over a longer period of time, more than 1 year, generally. Then look for seasonality. Does something happen in the summer or in the spring, etc.? Look for structural change. In the summer, does the electric bill go way up and then stay high for a while and then go down in the fall? Think about possible outliers. Now, don't just determine that there are outliers. Be very careful. These need to be clear. And we're going to learn a mathematical formula later to make sure that we understand what is an outlier. So be careful. Now, in this one, that is clearly an outlier because it has nothing to do with all of the other points. So make sure that it really is an outlier before you say that. If you see other points here, for example, this one went down, that one went down. Those aren't outliers because it's happening seasonally. Okay? So be careful. That's probably the number one mistake students make, is they want to find outliers where they really don't exist. And then finally, look for irregular or random fluctuations, because those types of time series graphs you're not going to be able to use to make predictions or to make any kind of judgment about what's happening. All right? So these are your definitions that I want you to, I don't want you to learn, you need to learn. You need to learn what a trend is and how to recognize one. Right? You need to talk about cycles, seasonality, structural change, and outliers, and finally, irregular fluctuations. So you need to be able to, when we're talking about these time series plots, you must use the correct language when you're working with those. Okay? So again, just a matter of looking at the pictures and determining it, and you're going to have to work on making sure that you understand those definitions for yourselves. Okay? So let's look at the exercises, and we just want to look at a few of these just to give us an idea of what you're going to be expected to do. And we'll look at some of the even numbered ones, and then you can do the odd ones. All right? So here we have a set of time series plots, plot A, B, and C. Complete the table indicating which of the listed features are present in each of the series plots. It's from 2014 to 2018, so you're going to be able to see some trends. If you look from here, this one seems to have a slightly downward trend, a decreasing trend, so you could say it's decreasing, but if you look, it's very regular in its ups and downs. So really what's happening here is, and it's over many years, not just 1 year, so you're getting cycles. All right? Then here, again, up and down. So, and it's fairly regularly up and down, so I would say that this one also has cycles, and so, or some major fluctuations in some periods. Okay? And this one seems to be increasing and on a pretty steady rate, so it wouldn't really be irregular. Doesn't show any seasonality. It's really just an increasing trend, right? Anything that you can justify, though, will work. So let's see how they define these. Sorry, just take a moment to load. Okay. So graph A, there's no general tendency to decrease in value from left to right, indicating there is a general, so decreasing, we said that, and it happened with, there appears to be some irregular, the remaining variation appears to be no more than irregular fluctuations, okay? So, oh, sorry, that's one. So decrease from left to right, so decreasing and seasonality, which is what we said, okay? There were no really regular ones. So just look and see what they have to, if you can justify it, then you can say it, but be sure that you can justify it. Okay? Now, here you're going to describe these. Clearly, the males are decreasing, females are slightly decreasing, but really pretty much staying constant, right? And then you can compare those two. So you would simply write out what you think about the difference in those smoking rates would be, right? So you're just going to make sure that your big thing here is that you're using the proper language. So all of these are just going to give you practice writing out some sentences where you're using the proper language. Okay? So what I want you to do then is I want you to do the odd numbered ones of these. So you'll just do 1, 3, 5, 7, and 9. And again, I'll post that on your weekly work, so you, in case you forget, you will have a chance to have it written out there for you. All right.